Our header here needs to be in a word that happens before the payload pointer. And we could represent it using this structure. Just to make the picture better, I'm going to expand out the space that I've used for my headers, and then just write block header there, because I'm going to put an instance of this block structure. Notice that because size is a size t, which is size is 8, that means this structure has to be lined on 8 bytes, and so that rounds up to 16, and that's great because a 16-byte block header will preserve alignment very simply. So that means the overhead, it's going to be useful as we implement this to have an overhead definition, and that's just the size of the block header. That's how much memory we have to add to every request from the application to get the actual size of the block. We're also going to very frequently have to go from the payload pointer to the block header. By the way, and this is very important, BP stands for the block payload, right? The BP pointers are always going to be after the block header to the program's view of memory. And it's going to turn out to be more convenient to use those pointers almost all the time. So we'll prefer to use a pointer to the payload, and then we'll get to the header by using this header macro on a payload pointer. And we do that just by making sure we're working in terms of bytes for pointer arithmetic, and then subtracting off the size of the block header. Then we get a pointer that's the address of the block header. And to use that pointer, we can cast it to a block header pointer and then get out the size or allocated fields. And we'll just make macros to make that a little more convenient, where getSize and getAlloc work on generic pointers to extract the size and allocated fields. We will also finally need to be able to follow the linked list, so we'll want to go from one block to the next. Again, because it turns out to be more convenient, we're going to go from the payload pointer to the next block's payload pointer. So that's what next block P does. It's next block payload. It takes a block payload pointer and does the right pointer arithmetic. That right pointer arithmetic is you want to go forward by the size of this block. So the size of the block is the blue region. This blue block header is the same as this white block header, so the arithmetic works out. We can just add the block size to get to the next block payload.